joining us. Today we're going to have a discussion panel on Glulam titled Old Products, New Tricks. Joining me again are Bob Kuserk with APA, the Engineered Wood Association, and Liz Connor with Unalam, and we're very grateful for them providing their expertise in this session. It is a copyrighted presentation. We are offering AIA credit, so if you have questions about that, feel free to email us at info@awc if you require further information. As Marcy mentioned, we are recording this webinar. And I'm going to guess that most of you took a look at the course description when you signed up, so I won't linger on this too long. But it is going to be a panel discussion, and we have our learning objectives for today as well, which were also included in our sign up and promotional materials. So with that, just to get an idea of who's with us today, we're going to do our only poll, and that's what's your profession? This one's easy because there's no wrong answer. We just ask that you answer in the blue poll window that popped up for you there.
We have 60% engineers, 26% code officials, and a smattering, just like 7, 3, 4 of everyone else. So no matter your profession, I am delighted. We are delighted that you are here.
I think today we'll have something that everybody will find interesting, but it's good to know who's out there, and that's me. So today I'm just going to briefly talk about primarily the NDS, or the National Design Specification, and how that deals with Glulam compared to other things that we might be familiar with in the NDS. So we're going to focus primarily in two spots. The first chapter we're going to take a look at is Chapter 5, which deals with a lot of the structural design requirements for Glulam, but also has a few other important references in there. And then I'm going to talk about Chapter 16 a little bit and fire design with some of the things that you need to pay attention to for fire design of Glulam specifically. After I finish up, I will also address just briefly some connection stuff, but that's really only a little bit one slide in Chapter 12 there. After I finish up, Bob is going to take over, and he will talk to us about some specifications and some other material that APA has that can help folks design and specify Glulam. And then Liz will close it out for the prepared portion of today's session with some information on the things you can do with Glulam from a custom standpoint. And then we will again have our extended Q&A session, so feel free to send your questions in while we're talking today. We should have plenty of time at the end to get to hopefully as many as we can. So again, NDS Chapter 5, that's the Glulam, or structural glued laminated timber, as it's officially known as, is dealt with in Chapter 5. That's the product chapter, and you'll see NDS 5.1.1.2 refers to ANSI 190.1, and I know Bob is going to talk about ANSI A190.1 as well today, so I'm not going to talk about it too much, just laying out here what requirements for glue laminated timber are in that standard. But the primary thing when we're dealing with Glulam is you want to make sure it has a grade stamp, and it's an approved grade stamp. So the requirements for what a grade stamp should look like, it needs to be, an accepted grade stamp. It can't just be something that's spray painted on there. That will tell you a lot about the material. We do have a definition in Chapter 5 of structural Glulam, or glued laminated timber, as we call it. You'll see that the requirements do state that the separate laminations, so that's the individual layers that we glue together to build a Glulam member up, cannot exceed 2 inches in net thickness. And there are permissions that it can be finger jointed, it can be end jointed, they can be bent during gluing to curve the beam. So you can have various shapes that are allowed that are all built up from nominal solid sawn lumber, typically 2x material to make larger sections. And in this table here, table 513, we show some typical net finished widths of glulam timbers. And you can see for the western species and southern pine, there are some slight variations. So if you're unsure of what your local supplier might have available, you might want to give them a call before you start specifying to make sure that you're choosing the correct size and the correct species for what's readily available. Another thing in Chapter 5 that we want to talk about is the properties about the X and Y axes. So the orientation of the glulam member matters. And you'll see that the X-axis is oriented parallel to the individual laminations, while the Y-axis is perpendicular to those laminations. So regardless of which way, if it's kind of oriented in an upright fashion, like what we see here in the left, or if it's on its side, in a flatwise fashion, like what we see here on the right, we do need to be aware of that and choose the appropriate properties for those axes. So we have bending values specified for both positive and negative bending about the x-axis, and we have bending values for the y-axis. Similar values are seen for compression, perpendicular to grain, shear, as well as the modulus of elasticity. So knowing the orientation of the glulam member is important. If we take a look at table 5.3.1, for those of you that have spent time in the NDS, this format of this table should be very familiar. There's one in pretty much every product chapter that we have that shows the different adjustment factors for glulam. So you'll see, depending on the design property, whether it be bending, tension, shear, or some others, you'll have to apply the various adjustment factors. And there are some specific ones that we see for glulam that we don't see for other materials. So things like this curvature factor, C sub C, the shear reduction factor, C sub VR. Those are ones that we don't really see in our other materials. So you wouldn't see something like that if you're in Chapter 4 designing a solid sawn member or a heavy timber member, for example. Other adjustment factor provisions that we need to be aware of for glue-laminated timber, the volume factor, which is C sub V, and the beam stability factor would not be applied simultaneously. So you need to apply one of those, but not both. And you'll see back here we have a footnote in the table 531 that states that the lesser of these adjustment factors should apply, of C sub L and C sub V. And also something that's a little different for those of you that might be used to designing with solid sawn timber is that the wet service factor. So typically in solid sawn lumber, we see that wet service factor, C sub M, the cutoff point is 19% moisture content. For glulam, we apply the wet service moisture content, or I'm sorry, the wet service factor when the moisture content is greater than or equal to 16%. So it's a minor difference, but it is important. So you want to be aware of that. Now going into Chapter 16, this is the fire design of wood members. And Chapter 16 in the NDS is used for fire design of any exposed wood member. So this applies to anything you're designing with the NDS. So many of the provisions for fire design of glulam are not specific to glulam. They're used for any wood member. But there are a few instances where we do need to pay attention. There are some differences in the specification. So Chapter 16, just to remind some folks that might not be as familiar with it, it only contains design provisions for allowable stress design. So if you're doing an LRFD design, you would have to use a different method. This would only be something you could use for ASD designs. But if you look in NDS 16.2.4, there are special provisions called out in there for glulam beams. And it essentially has two provisions. So if you're designing a beam for a fire resistance design of 1 hour, you would replace one of the inner core lams. And I know Bob's going to get into some terminology and explain this a little bit better, but just imagine, if you will, this beam here in our photos on its side. So imagine we're replacing one of the inner core lams that's adjacent to a higher grade, higher capacity outer tension lam. We would replace one of those with the higher capacity, higher grade tension lam. If you're designing a beam for 2 hours, you would replace 2 laminations, or 9 minutes or 2 hours rather. You would replace 2 of the inner core laminations with the higher quality tension laminations. And essentially this is, you know, the thinking with this is if you have a section lost, that it will occur on those higher capacity outer tension lams, because that would be what is exposed to the fire first. So as those lams experience char, you would still have higher quality material left after that 1 or 2 hour fire exposure to provide some residual strength for safety in your fire design. And so the last slide I have is on chapter 12, and this is our connections chapter, and this is just something brief. Just again reminding that there are some provisions specific to glulam. So I want to point you to NDS 12.5.1.3, which also references table 12.5.1F. And this gives us perpendicular to grain distance requirements for our outermost fasteners in structural glulam timber members. So this sets some distance requirements, because when you start having members that are in the same connections that might be farther apart, you can develop residual stresses that can lead to splitting or other failures to connections. So limiting the distance between those outermost fasteners in a connection, in a multi-fastener connection, can help reduce some of that residual stress, and it produces just a better design on the connection. So that was all I've got. So what we're going to do next is give it over to Bob.
Hey, thank you, Lori. That was very informative. Hopefully everybody can see my screen.
Yes, it looks great.
Okay, I'd like to verify that always when I start. So I'd like to welcome everybody to attending our webinar and panel discussion today on behalf of APA. As was mentioned, I work for APA, the Engineered Wood Association. A little background on APA. It's a nonprofit trade association, and we represent manufacturers of really a variety of common structural engineered wood products. In addition to quality verification and product testing, it allows APA members to place the APA certification trademark that Laura talked about on the products. APA also conducts research to improve engineered wood construction systems and educates users and specifiers on products, proper use, and potential applications. I'm an engineered wood specialist. I'm located in New Jersey. APA has engineered wood specialists spread throughout the continental United States. So if you need to reach out to any of us, go to our website, apawood.org, and you'll be able to find our contact information there. I just wanted to really start with a quick review of glulam history, where it's been around for a long time. It was first introduced in Europe in the early 1890s. A 1901 patent from Switzerland signaled the true beginning of the glue laminated timber construction. One of the first glulam structures was erected in the U.S. at the USDA Forest Products Laboratory in Madison, Wisconsin, and that structure, erected in 1934, is still in service today. But one of the significant developments in glulam really happened in 1942 with the introduction of fully water-resistant phenol resorcinol adhesives. This is what allowed glulam to be used in exposed exterior environments without concern of glue line degradation. The first manufacturing standard for glulam was published by the Department of Commerce in 1963, and the most recent standard is the ANSI standard A190.1 that Lori mentioned, and this really ensures the products are manufactured and stored to the standard, and that's what our quality service division does. So the trademark gets put on the products. As mentioned, APA is a trade association. We represent manufacturers. Their information can be found on our webpage. If you go to the manufacturer directory link at the top, click on the Glulam tab. It'll give you a list of our manufacturers. We have 25 members of APA that produce glulam, and you can be able to get their contact information if you want to reach out to any of those members to find, more information about their products. Today, I'm going to go over some of the design tools that APA's developed that'll help you in specifying glulam and, kind of demystify a little bit for you. But first, I'd like to, start talking about some misconceptions. When I go talk to people about glulam, if they're not familiar with it, there's a lot of misconceptions about glulam. So I kind of will run through some of the myths. The first being that glulam is only for custom exposed applications. While glulam is often chosen for their beauty and exposed designs, such as rafters, vaulted ceilings, long clear span ridge beams, they're also ideal for hidden in the wall structure applications. Everybody thinks of that exposed application, but we can put it in walls. We can put it in floor beams, headers over small and large windows. Second myth is that glulams don't span as well as other engineered lumber products. Reality is that glulam is inherently strong, it's dimensionally stable, and makes it suitable for a wide range of applications, including long span roof beams, heavily loaded floor beams. It really falls in the same range of design values that is typical for what you would see with other engineered lumber products or structural composite lumber. Stock beams typically come in 60-foot lengths, commonly used to create spans 20 to 28 feet and greater. Come in a variety of sizes. It's an ideal option for framing large openings and for creating that great open concept rooms that everybody renovating their homes is looking for these days. Third myth, glulam beams are only available as cambered members. I talk to people, they say, oh, they always come cambered. While they are as available as cambered, to negate the possible adverse effects of long-term deflection, uncambered beams are common and are readily available. Most residential applications require very little or no camber. Uncambered stock glulam is an ideal choice for these applications. If, however, camber is required for long spans, custom beams are available through your local dealers or, talk to the manufacturers. I think Liz is going to talk to them to see some really great uses of glulams in this slide here. And Liz will talk to that a little more. Some people think glulams are expensive. Stock glulam beams found in most contractor yards are cost competitive with other engineered lumber products of the same range and sizes and dimensions. Fifth myth, that glulams are hard to get and limited in size. Glulam beams are readily available in both stock and custom sizes. Stock beams are available in all the major markets. And one advantage, they're available in widths that match 2x4 and 2x6 wall constructions. So there's no need to furrow out a header if you're putting in a wall, if you're using it in a garage portal application. They're available in I-joist compatible depths, so they can fit flush in a floor system if you're using an engineered wood system. And the last myth, and this is what we're really going to get into, and you talk to people, the last myth I'd like to address is that specifying glulam is hard. In reality, it's not, and that's my goal here, is to kind of simplify this for you. So when we look at glulam combination symbols, the glulam combination symbol identifies the allowable stress of the material, how the plies are graded, if they're visual and mechanically graded, a stress combination number, and the wood species. I mean, that sounds a lot. It seems kind of intimidating, but it leads to the question, what is really important if you're specifying glulam? I'd like to emphasize today that there are many stress classes listed in the codes, but I'd like to focus on two stress classifications, the 24F 1.8E and the 30F 2.1E, as these are commonly stocked materials. I'll explain more what the designation means. So I'd recommend you specify allowable design stress class and not worry about all these specific layouts. I will mention, Lori mentioned, we need to understand that glulams do not have the same strength properties throughout the depth of the member. We put the good wood where we need the good wood, and that's how we engineer the beam to get the most strength out of it. If we consider it a balanced layup, the beam has equal capacity in both the positive and negative bending, and is primarily used in continuous beams or long cantilevers. We use this if we don't know if there's going to be a reverse bending on the multi-span application. However, if we look at an unbalanced beam, they have unequal capacity in the positive and negative bending, and we primarily use this in simple beam applications where we know that the top portion of the beam is in compression and the bottom the bottom side is in tension. So we put the wood, the highest strength wood, in the tension lamps because that's where we need it, and we can go with a high strength in the compression lamp, but it's not the same strength. So because of this unequal capacity, unbalanced beams do have a top and a bottom and must be installed correctly. If you go out in the field and you look up and you see the word top, chances are that beam's been installed upside down. So let's take a little bit closer look at that grade stamp because there's a lot of information. I think that's why Glulam feels intimidating. So taking a closer look at this stamp, we see that it contains several critical pieces of information that's good to know if you're specifying beams. It seems confusing, especially when compared to common engineered lumber like LVL or PSL, where they typically only give you a bending stress FOB and a modulus elasticity E, typically noted for those types of products. So what this table tells us, like engineered lumber products, the allowable bending stress is noted as a 24F, and that represents 2400 F sub B. We don't list the E value in the trademark, but we'll talk about that in a little bit. The V in the designation tells us that the plies in the glulam were visually graded or mechanically graded. If it was mechanically graded, that would be represented by an E. I'd like to think of the 4s, that's kind of the recipe on how the plies in the beam are laid up. So this number really tells the manufacturer how to make the beam. Doesn't communicate a lot to the information that you need to worry about if it's a V4, the mechanical grading in the 4 is kind of the recipe to produce the product. The trademark will also tell us an appearance grade. If the beam is balanced or unbalanced, it'll tell us the wood species, if the beam is cambered, if the mill has laminations proof loaded, and the mill number that identifies the manufacturing mill or is made. It also identifies that the member is made in conformance with ANSI A190.1 standard for glue laminated timber. If you need more information, suppliers can assist you in understanding this information, or feel free to reach out to any of our engineered wood specialists throughout the country. And I know that seems like a lot. Typically compared to just thinking about a bending stress and an E value, this does seem intimidating. One thing on Glulam is you don't focus on appearance grade with other ELP products, but you may with Glulam. So it's an important benefit of Glulam that it has that possibility to get appearance grade classifications. So why else do we think it's hard? So if we look at that ANSI 117, and I don't expect you to read this table on the right, we'll see that there are 50 different combinations. And that's, I think, why people see this is very intimidating. It's like that big steel table. There's just so many choices. So what we try and do is simplify this a bit. ANSI 117 takes those 50 layups and they break it into 7 reference stress classifications, as shown in this table, where the group design values are listed. And then we take this further. We mentioned that there are 2 stress classifications that are most commonly available with stock Glulam. So this layout is a little more similar to what you see with structural composite lumber. If we look at it, we see that F sub B value and we see an E value, 1.8 E, so it's a 2400 1.8 E product, or 3000 bending 2.1 product. A lot similar to what you're used to seeing with structural composite lumber. For this presentation today, I'm going to focus on just kind of looking at this 24F 1.8 E classification. So if we looked at that we'd see that in that category, in that stress classification, we'd see that we've got 7 different layups that are available with that. So the key is if we specify to this stress classification, all of these products will work. We're really designing to the lowest common denominator of that stress classification. And that's kind of how we make it a lot simpler. So some of the design tools that AP has to assist specifiers We've got developed a lot of design-based literature to assist you. You can find them on our website at apawood.org. In addition to our literature, there is standalone literature that you can get from the Glulam manufacturer. So this table here includes our Glulam floor beam guide that has tables that lay out different tributary widths that can be cross-referenced against column or beam support span. And this is going to allow the designer to select an appropriate floor beam. Note that this table is for a multi-span application. This is especially important with unbalanced beam, as the different compression and tension stresses need to be considered in selecting the beam. So this table is based on that reverse bending. So in addition to this multiple span table, simple span tables are also included in this literature piece. So it's important to make sure you're using the correct tables. This guide also provides relevant details to assist in the installation of Glulam beams and floor applications. We also have APA's Glulam garage door headers, which provides tables to allow for selection of an appropriately sized Glulam beam over garage door for different width openings. They make excellent garage doors. I said they come in 5.5 inch width, so if you're doing a 2x6 wall, you don't need to fur them out. APA also has a substitution of Glulam beams for steel or solid sawn lumber. And this will provide guidance to assist in the substitution of Glulam beams for steel or lumber. The publication provides and guides the specifier to select laminated timber beams of equal or greater strength and stiffness that can be substituted for sawn lumber or steel beams that may be sized through other published span tables, such as the IRC if you're looking at wood spans, if you're looking at a steel book that has steel specifications. Note that all three publications are using the 24F 1.8E reference classification, so all beam layups, those 7 layups included in the classification, would be acceptable. APA also published literature regarding holes. You're familiar with structural composite lumber, and we know we can cut some holes in those beams. You can do the same with Glulam. So for horizontal holes in Glulam beams, the different design criteria exist, and they're detailed in our APA technical note, field notching and drilling of glued laminated timber beams for both simple and multi-span applications. Generally, the holes should be in areas that are 50% of the design for bending or at the ends close to bearing. So for those familiar with hole cutting criteria with other engineered lumber products, Glulam beams are really not so different. Recall the beauty of wood. We talked about that with Glulam. Everybody wants to put that Glulam ridge beam up there. Unfortunately, everybody wants to put a ceiling fan up there too. Within this document, APA provides guidance on the drilling of vertical holes through the member as well. The specifier, just keep in mind the vertical holes drilled through the depth of the beam. It does cause a reduction in the capacity, so your engineer should check it. And basically, it's proportion to the ratio of 1.5 times the diameter of the hole of the beam width. Our field notching guide also provide information on notches. You get that beam up in the roof, you need to cut that sloped cut or a notch. There's guidance in this document for you as well if some of those field modifications are required on your structure. Mention the small hole guide. Talked about APA quality assurance. We also have a technical division. Our technical division, service division, has recently done some research because people are looking to put larger holes in Glulam beams. So we did some research, over the last couple of years, and this research actually allows holes potentially up to 2/3 the depth of the beam. But I will note it requires engineering analysis. It's not as simple as just going to that hole chart table. You really need the engineer to look at the beam, look at the hole location, look at the stresses. But we do provide guidance. And this technical note is available on our APA website. I'd like to talk a little bit about checking. When people get Glulam beams, they might see something that looks like checking. It might get confused with the lamination. I'll note that checking is a natural phenomenon that can occur in Glulam, and it's associated with the natural drying of the wood. Shouldn't be confused with the lamination, which is a deterioration or a failure of the glue bond. With the introduction of wet use adhesives, moisture-based lamination for Glulam was virtually eliminated in the U.S. And this was assured in by the Glulam standard requiring adhesives to meet the ASTM D2559 standard for adhesives for bonded structural wood products. for use under exterior exposure applications, but you might see some checking. As we think about how wood reacts to moisture, first wood swells and then it shrinks, it gains, it loses moisture in response to the changing relative humidity, and to a far lesser degree, temperature can impact it as well. If the difference in the moisture level between the core and the surface of the wood becomes great enough, the internal stresses associated with these dimension changes can induce tensile stresses perpendicular to grain. These stresses can result in seasoning checks developing across the annual growth rings. It's common in solid sawn lumber beams. But as I said, checks should not be confused with delamination. Checks are noted by the presence of torn fibers, so you'll see wood failure. Should not be confused with the failure of the adhesive, which we would call delamination, where the small lamination surface is seen and we don't really see any wood fiber tear. Such checks are seldom a structural concern, but they do impact the aesthetics of the beam. Common checks you may see are end checks that originate and generally stay at the location of the end of the member. You may see a side check where the opening is parallel along the side face of the member, or you might see a bottom check that occurs on the bottom face of the member. APA has developed documentation to help designers and design professionals, with this, to see if checking in the beams is really a concern. You can refer to APA's technical note, Evaluation of Check Size and Glued Laminated Timber Beams. This flowchart is a useful tool in the field to assess checks in the field to see if they're a structural concern or if they're just no structural concern, or if they are a constructional concern where you might need to get your design professional involved. And last thing I'd like to mention, some of the recent research that APA and the USDA Forest Products Laboratory has been conducting is interest in using engineered wood products in Type 3 and Type 4 construction has been rising in recent years. The wood industry has been heavily engaged in promotion multifamily and light commercial construction Type 3 and Type 4 buildings. So Type 3 and Type 4 construction is a type of construction in which the exterior walls are non-combustible materials, except that fire-retardant treated wood framing is permitted within the exterior wall assemblies of 2-hour ratings or less. So to address this opportunity, APA, in cooperation with USDA Forest Products Laboratory, we worked to develop ASTM standards for the evaluation of FRT glulams. Recently, we published a technical note summarizing the results of this pilot test program, examining the structural properties of FRT glulam that can be found on the apawood.org webpage. For structural design, the actual treatment and hydrothermal effect on the glulam properties will still need to be attained from the treater who provides the fire retardant treatment, for the process. But it's something I want to let people know that, APA is working on getting, FRT glulams out into the marketplace as we do see some demand for this product. And with that, that really completes my portion where we hopefully focus on stock glulam and some of the APA tools that can help at this point. So I guess I'll pass this on. I don't know if Lori's going to take control. I think we'll pass this on to Liz at some point. Thank you.
Yes, I'll go ahead and give it to Liz. Thank you, Bob. That was really informative.
Cool. Now that we have this great understanding of what glulam is and some of its capabilities, let's get into how it's manufactured, and we'll also talk about some specification items when you get into doing custom glulam projects. So this is really focused on the custom end of the industry. Just a side note, when I say we in this, I'm referring to the Royal Glulam we, to nothing and no one in particular. So I like to put it in the context of the engineered wood product world. So solid lumber and heavy timber, your 2x4, 6x12, etc. You have laminated veneer lumber, LVLs or microlams, parallel strand lumber, also known as PSL or Paralam. And all of these are commodity products that are limited in their structural capabilities, limited in the dimensions available. They're also limited in their appearance qualities. And then we have cross-laminated timber, the hot new exciting product, where that is panels of lumber that have been glued together with each layer, the grain running perpendicular to the one before it. That also has its limitations. It's currently only being used basically for floors, walls, and ceilings. And then we have structural glued laminated timber, which I'm not sure has very many limitations. The slide here is to show that we're taking nominal lumber right here. This is like 2x4 to 2x12, and we're manufacturing custom projects. So this is what you see for lumber. These are LVL standard sizes. These are standard sizes available for PSLs, and then this is what's available for Glulam. This right here is 24 inches wide by 60 inches deep. And this really tall one right here is 8.5 inches wide by 9 feet deep. So with Glulam, your limitations really only come with shipping restrictions and the facility from which you're getting your product. Okay, so like Bob and Lori talked about with stress combinations, we need to know all of that and the finished dimensions in order to start manufacturing this. So the first thing we do is we order our lumber based on the finish width that's going to be required. So if we're making a 5-inch wide beam, we're going to order in a bunch of 2x6. And like Bob said, it does get graded differently. So when we get the material in, we're going to organize it into 2 piles. We're also going to check the moisture content to make sure it's between 12 and 16%. And if it's not, we'll let that dry out. But when we're grading, we're looking at the quantity and the quality of the knots. We're looking at the density of the grain and how parallel the grain is to the edge of the board. So we'll take the more dense material with few to no knots, put that in one pile, and the less dense material will go into another pile, and then we will assemble those densities based on the specified stress combination. Okay, so we have our width, now our length. We take our random length lumber and we send it through a scarfer that's going to cut all of these finger joints and apply a melamine resin, and then they'll get loosely fit together and sent through a microwave tunnel to cure in just a few seconds. So with this process, we can make whatever length we need, you know, from 40 feet to 175 feet, whatever's required for the project. All right, we have our width, our length. Now we make our depth. This is where we take our 100-foot long boards and we send them through a glue spreader. That's going to spread the phenol resorcinol on both sides, make sure it gets everywhere. And we take these boards, we lay them up on their narrow edge against these forms that have been bolted into the floor with these tracks down here. With these forms, we can set them to whatever profile or radius we need for the project. What you see here is a 20-foot radius that's set up to make a pitch and taper beam. So we lay the boards up, we take these pneumatic wrenches, and we basically start at the center line of the curve and just push it in, almost like a giant vise. That will sit overnight to cure fully. And you can see there's uneven plies, there's glue squeezed out. So the next step is to send it through the surface planer. This is where we get our different dimensions from the rest of the lumber and timber industry when it comes to custom manufacturing, because we're smoothing out all of those edges, cleaning up the glue, so you get a nice exposed face. Next step, okay. Glulam is a material that's as fully finished and as fully fabricated as possible within the manufacturing facility. So we're going to do all of your bolt holes. We will do all of your angle cuts. If you are using knife plates, we'll do the kerf cuts. Whatever needs to be done, we're going to do as much as possible in the facility. And in some cases, we can either partially or fully assemble some components of a project. So you can see here on the right, there is a fully assembled scissor truss. It has all concealed steel connections, which can be fussy to put together in the field. So it was worth it to pay extra in labor, extra in wide load shipping, to have it fully assembled to just be picked up and set down where it needs to be. One of the amazing benefits. And here is a little video of that whole process from finger joining to gluing. So those rollers are pushing those joints together nice and tight. The glue room floor, it's going through the glue spreader, tossed up against the forms. And just pushed again. Now that video obviously goes very fast, but it is a very fast process as we get only about an hour and a half to work with the glue before it starts to cure. During this whole process, we adhere to the American Institute of Timber Construction Standards for Manufacturing, AITC. I feel like AITC and APA, when it comes to standards for manufacturing glulam, they're kind of 6 of one, half a dozen of the other. So you're going to get basically the same quality product and the same strength properties, etc. But we have an in-house quality control manager that will make sure we're following the appearance grades, regulations, keeping things within tolerances, and we do daily testing of the glue lines and the finger joints, and all of that will get recorded and audited. Note on fire safety, they talked on that, but it's so predictable in a fire because what happens, it behaves like a big single heavy timber member. So it ends up charring on the outside, and that insulates the core of the beam so it can maintain its internal strength. And I kept this in because this is my favorite slide. It is 2 steel I-beams that have just fainted like Southern bells across the glulam beam after a fire. So glulam's pretty great. All right, now we're going to talk about specifying glulam. So we'll go over materials, dimensions, appearance, and your steel options. And this is kind of the bulleted quick version, so we'll just blow through this. All right, materials. So there's 2 main species when it comes to glulam manufacturing. There is Douglas fir, which is mainly used on the West Coast. That is where it's grown. It's accessible. It's more economical. And then there's Southern Yellow Pine, which is mainly used on the East Coast because that's where it's grown. It's more economical, etc. When it comes to doing straight projects, they pretty much have the same strength properties. When it comes to doing curved projects, then we have some changes in what they're able to do. So Southern Yellow Pine performs better in radial tension than Douglas fir. So on the East Coast here, we direct people to using Southern Yellow Pine when they start to do a curved project. It says other here for material, and the charts there say RM, stands for red maple. There are alternative species you can specify, but we have a lot of trouble getting the right quantity and quality of those materials, and we also need to have someone that can grade them for structural purposes. So sticking with Southern Yellow Pine or Doug fir, you won't have any issues with availability. And these are just the visual differences between SYP and DS. On the left, you have Southern Yellow Pine. It's very consistently yellow. It's not their larger. It doesn't have as many small knots. And then on the right, we have Douglas fir, and it's very colorful. So even within one board, within this beam here, it goes from milky white to pink to red. And here you can see a finger joint where there is obviously a stark difference between the boards. If you want that striated, colorful look, great, go with Doug fir. If you're going to stain it, at least if you're on the East Coast, go Southern Yellow Pine. You'll have a more consistent finish. Another consideration when specifying your material is if it needs to be treated. I have CCA shown here. There are other treatments, but this I think is the most ubiquitous. It's chromated copper arsenate. It's a water-based treatment that does not off-gas. So this is what we use when we're doing high humidity interior projects, such as pools, hockey rinks, etc. Also where people are going to be in direct contact with the material, like at the bottom here, this pedestrian bridge, which was shipped fully assembled. All they had to do was lift it up and set it down. That's one of CCA in a heavy timber application is safe in that context. Okay, standard sizes. So Bob has slightly different standard sizes than other manufacturers. So I'm just going to go over these briefly. I think if you always stick with the more narrow of the width, you'll always be able to get the size you need. So standard width, we have 3 inches, which comes from 2x4, 5 inches comes from 2x6, 6.5 inches comes from 2x8, 8.5 inches comes from 2x10, and 10.5 inches comes from 2x12. So 10.5 inches is the widest we can make using a single size of lumber. Anything wider than that, we're going to do what's called a combination layout, shown here on the right, where we have 2 different sizes of lumber and we stagger the joint to build the extra width. I think 24 inches is the maximum we've done. We can stretch it to 26 if someone wants to try. Our depth, also in the glulam industry, are slightly different. We're taking the 2x material and we have to plane that to clean it up, even out the finger joints, and open up the pores in order to glue it. So instead of 1.5 inches, it's 1 3/8. So that's what we build our multiples in. For curved projects, less than a 20-foot radius, we use 1x material, so that's in multiples of 5/8 when you're building your depth. CCA is slightly different multiples, but your manufacturer can help you find the closest standard. Another note on dimensions, we're very particular on dimensions in the glulam industry. So we use actual finished dimensions. And we work typically within about a 1/16 of an inch for our tolerances. Steel, I think, is a 1/4 of an inch, and concrete is just out of control. So we're very precise. And one thing that is important to know when you're specifying the dimensions is we always list the glue line width first, because that tells us what size of lumber we need to use. So this, say it's 6.5 by 8 1/4. You flip it on its side, it doesn't become 8 1/4 by 6.5. It stays 6.5 by 8 1/4. Its orientation is just different. Okay, appearance grades. So there's 3 main appearance grades. Most of what we do and what you have seen so far from Lori's presentation and mine is architectural grade. So that is where there will be no high plies or low plies, no glue smears. There'll be knots in the beams, but there won't be any loose knots or voids. So those will get routed out, and we'll fill those with a clear wooden plug. And all of the exposed corners of the members will be eased. That's the best way to go if you're doing a building. Industrial grade is an option. That's when appearance doesn't matter for things like salt storage sheds, tractor bridges, etc. There's not a lot of difference cost-wise between industrial and architectural, and then there's premium, which is just like architectural, but we have to do a lot more plugging. So that can really interrupt the natural flow and look of the grain, the whole purpose of using wood. So we try to steer people away from that for buildings, but we do use it on furniture, stair treads, mantles, etc. Another thing you're going to want to keep in mind when you're specifying for your appearance is if you want it to come sealed or stained. Each manufacturer has their own standard colors available and their own standard sealers. Another option, which is super fun, is a rough-on finish. So we're in upstate New York where there's, the Adirondacks and the Catskill look, where it's that very heavy timber focused design aesthetic. So in some cases, heavy timber, the sizes you need don't exist. They don't make trees that big anymore. But what you can do is you can use glulam to compensate for the lack of, other materials with a rough-on finish. So on the left here, we have kind of a bandsaw cross-sanded finish. It just gives it a little bit of texture. This project has curved beams on it. So that was basically the only option for this project. And then this one right here is a chainsaw finish, where they literally take a chainsaw and just walk it down the beam. Gives it a really rough look. And this project had beams on it that were 10.5 inches by 48 inches by 80 feet long. So heavy timber was not an option there, but it is a custom option with Glulam. Okay, now we'll talk about steel. Steel is an important part of Glulam design. If you can't design it yourself, there's 3 options you can specify so the manufacturer can design it for you. So fully exposed steel and hardware is the first option. That's our default. That's where you have exposed side plates and hardware. This is the easiest to fabricate for, easiest to design and draft for. And then we have concealed steel with exposed hardware. That's where the steel plates are concealed within the beams and the hardware is exposed. It's a bit of a softer look. It does, cost a little bit more. It's a little more design work, more fabrication. Those things will be pre-fit to test to make sure they're going to fit together in the field. So it's a little extra labor on that end. And then there is fully concealed steel and hardware. So in some cases, this can be pretty simple. So on the bottom right here, we have a Tudor arch with purlins. Those purlins just have a simple angled hanger off of the top of the arch. So it's just doweled in to the end of the purlin and hung off the top of the arch. Pretty simple. Up here, we have a partially assembled hammer truss that is being held together with countersunk and plugged hardware. You can see the holes back here and right there. Pretty simple. And then we have this, which is bonkers. So it is a modified scissor trusses with bottom cord bridging on a hip roof. So right here at this connection point closest to us, I think there's 12 or 13 beams coming together at one point, fully concealed steel. So it can get really expensive because that's a lot to design for, it's a lot to fabricate for, and you need an expert installer as well. But one thing that's great about Glulam is it will get pre-fit within the manufacturing facility. So it should go together on site. And this is that steel connection here on the right. That is the engineer of the project. He is 6'3". This connection is basically 6'3". I think it's like 700 pounds. It's insane. And all of this needed to be pre-fit to ensure a smooth install on the site. And some other things, I know Bob was talking about holes in Glulam, which is great to have standards, but sometimes we can get pretty nuts with the fabrication. This here is a beam that has had to accommodate a 24-inch diameter HVAC duct. So we were able to taper the beam wide enough at one end to compensate for that loss of material. You can get really custom, you can really get around a lot of design issues. This is an example, like I said, some things can be fully assembled and shipped to the site for a clean, efficient site. And then this I like to show because, yeah, we can do the houses, we can do, trusses, but this is a span that's 210 feet made out of Glulam arches. They're 10.5 by 48 inches. They're about 135 feet long each. But Glulam has very few limitations. So do everything out of Glulam from now on. It's fantastic. And that's it. I think that's the end of me. So I'll give this back over.
Thank you, Liz. I will take it back just a moment here. All right. So, thank you, Bob and Liz. That was really great. There we go. All right, we had a lot of questions come in, so and I see we still have quite a few coming in, so we can jump right into that. The first question that came in was related to the modulus of elasticity, so I'll go ahead and take this one because I'm the probably the nerdiest one. But no, it's related to the modulus of elasticity specified in the NDS supplement for designs. So when we take a look here, we see that we've got three different ones here. We've got an E sub x true, an E sub x APP or apparent, and E sub x min. So if we go down to the footnotes, footnote 11 here, we can see what the difference is between those. So E sub x min is comparable to the E min that we have seen, that we might be familiar with in our solid sawn lumber designs, and that value is used for your stability calculations. So if you're calculating, for example, your beam stability factor, C sub L, you use that E min value in that calculation. Now, if we look here in the footnote, we see that the E sub x APP, or apparent moduli of elasticity for the x direction, is for use in the beam deflection calculation. And there's also corresponding E values for all of these in the y direction. So that's for your reference moduli of elasticity that we might be familiar with from solid sawn. That would correspond to just the kind of plain E. And it is defined in NDS 5.2.7. The E sub x true is a shear-free moduli of elasticity, and that's for use in beam deflection calculations when we don't need to consider shear deflections. So if you have a really small span to depth ratio, we might not need to consider shear deformations in that deflection, so we could use that E sub x true for that calculation. So, oh man, all right, a lot of other questions coming in. We'll do our best to get as many answered as we can. So let's see. The first question, I think this one might be good for Bob. Bob, I know Liz had talked about some of the architectural and industrial classifications of Glulam, the appearance grades. Can you talk about, do those appearance grades have any effect on the structural capacity of the Glulam?
No, they really don't. So you can use specify any of those appearance grades for what you're specifying, so they don't really affect your structural calculations or capacities. They're really just not part of the equation.
Yeah, great. Another one for Bob. Some questions on delamination versus checking, and some folks wanted to know if you could offer any pointers for if they're out, inspecting glulams that might be in situ. How could are there easy ways to tell on site when you just look at it, or do you need to get it under a microscope? What kind of tips could we offer to engineers?
Yeah, I don't know you really need to get it under a microscope. The thing to look for, because a lot of times these checks do happen near a lamination in the beam, and that's where I think some confusion happens. What you need to look for is, are you seeing any wood tear in there? So that's what you got to try and get in there and look at the wood tear. Where if it looks like really clean, you're seeing clean glue lines and you don't see wood tear. Those are the things that you need to look for in the field. Don't think you need a microscope, a magnifying glass. A good light, measure the length of the check, measure the depth, get a thin ruler to get in there and kind of measure it to make your assessment.
Excellent. Okay. Question about availability. So this one might be good for Bob and Liz to both answer. Talking about the typical widths, how do folks know 5 1/8, 5 1/2 for the member width? How should folks know which one to design with, and should they just call their manufacturer, or what's more commonly available?
I mean, go ahead, Liz.
Sorry, go ahead, Bob.
No, I was just going to say, as far as the stock material, I mean, always the best way to find out what's available is on any product, if it's Glulam or just even dimension lumber. You know, call your lumber yards. Same with steel too. Call your lumber yards, know what they're stocking. As I said, more of the stock stuff, you know, the standard stock, you know, you can get into those common widths and I-joist compatible depths. But always call the lumber yard. Even when you get into wood species, you should check with your lumber yard what's available in any local market. It can be different.
Yeah, that's my advice. Always just defer to the manufacturer that you are going to get it from. There are other dimensions available if you need to do something like fit within a certain size wall or whatever like that. There are other options. They just will incur costs, and that's a consideration. So I always say just use our standards.
Great. Here's a production question. So when we have multiple lambs that are stacked across a width, so if we had a beam that, you know, was 10.5 inches wide or wider, do we glue the vertical joints between those lambs, or are we only gluing the faces?
No, we're only gluing the faces.
Excellent. And that's
there's requirement to glue the vertical joint.
And in my experience, you know, research has shown that typically those vertical joints are glued, that it doesn't add anything to the capacity, and they don't really do anything, just waste glue. So
yeah.
Question on this is another manufacturing question. Liz, are you aware of any Glulam manufacturers using CNC fabrication techniques or anything along those lines for Glulam?
So I think out west, where Glulam is a huge industry, there are quite a few, and I'm sure in Canada they have CNC fabrication. We have a CNC machine, but we use that to create, when we do a curve project or a really complicated project, we have to make a full-size plywood template of the beams so we can set the profile for the curve or make sure we're, you know, doing all of the fabrication correctly. Just another check. So we use the CNC machine for that, but I think out west they use them more often. We need to be a little more nimble because we do such crazy custom stuff, and we don't repeat a lot of the same fabrication over, you know, throughout the day. So CNC use isn't as efficient for us anyway.
Yeah, so it probably depends on the mill and the typical type of product that they're generating. So for custom products, it may or may not make sense, but interesting. Liz, here's a question about your 210-foot span arches. How did you guys ship those to the site, and was there what on-site assembly had to occur for those?
So,
or something of that scale?
Not a lot of on-site assembly. It just has those, you know, the connection at the peak and the connections on the concrete, but and we had to do this before to a project in Indiana. So we take the arches and we had to build a special rack that had them cantilever over the front of the truck bed. And then we set them, I might be able to show a photo.
While you're pulling that picture up,
on top of it.
We can talk, we can have a couple other questions. Okay, if we're in an area where we have moisture content exceeding 16%, what are our design options? So the first option is to obviously just design it for wet service. So apply the C sub M factor. So that's something you'll need to do. If you are concerned about longevity, that's where you could start getting into some of those CCA treatments like Liz talked about. Bob, do you know, do they do some naturally durable glulam materials? I think they're more common in the western half of the country.
Yeah, you're right. I tend to see that more in the West, but they can ship wherever. I've seen some of it shipped to the East Coast. So if you're looking for naturally durable wood species, I wouldn't dissuade you from specifying that if that's the look you're going for, even if you're on the East Coast. Like I said, everything comes down to money. Call up the manufacturers, talk to them about it, and see what it would cost if it's worth your while. So there is some of that produced, more so in the West Coast, but you could get it here on the East as well.
And Liz, I see you've got your picture up there.
Yeah. So this, because I know this is going to come up in your lives a lot. This is how you ship 135-foot long arches. Now you know.
That's impressive. That is. So
yeah, it took some ingenuity.
So do you guys typically design for transportation loads as well as part of your design? Or is that something that kind of goes on a case-by-case project?
It's a case-by-case project because it's kind of hard. So there's two factors we have to think about is maneuvering the beams themselves within the facility, because we have to flip these beams in order to finish on the other side of them and do fabrication on the other side of the beam. So making sure that it will fit within the height restrictions of flipping a beam in the manufacturing facility and then the shipping restrictions. But those don't come up too often because you can just ship a wide load or ship it extra long. So having projects like this come up are every once in a while. We have to consider that in the design process.
Great. We had a couple people ask about field fabrication of glulam and if that's allowed. Bob, would you like to take that one?
Geez, I don't know that I really know the answer to that, Lori. It would be, certainly, something somebody I suppose could build, but I don't know how it would be certified.
I think it would be tough to comply with the AITC, or I'm sorry, the ANSI standards on that one.
Yeah, I think that would be its own design thing. I don't know who would.
There are requirements for pressing the adhesives. We saw Liz shared some pictures of that. I would not recommend field construction of glulams because again, you'd have to have them inspected and have a stamp applied. So anything that doesn't have a stamp would not necessarily be considered code acceptable material. So field built glulams are something that we certainly would try to steer folks away from that. So you certainly can use other means of connection. Nail laminated timber is out there and has been in the codes for quite a long time. So there's different options if you have requirements of field construction. Here's another question for Bob. Can you talk a little bit more about fire retardant treated glulam? I know we had you had mentioned the publication APA has on that, and that we as an industry are working towards getting some FRT glulams out in the
availability still could be challenging. As I said, it's something we really just started working on to get the ASTM standard developed so we get consistency across FRT glulams. Right now, I don't know availability of who would be sending it to you, but before, treaters would take glulam and they would treat it, and design values were kind of all over the place. So a lot of what the ASTM standard does is it's going to provide consistency across the industry. So that's kind of where we are. Like, it's only come out in the last, I think, about last year, probably just a little over a year ago, we came out with that ASTM standard got developed. But availability is still kind of up in the air right now.
Yeah, as a manufacturer, we have found that we haven't been able to glue it consistently, and it's stay laminated. So I don't know if that's an issue of, tweaking some of the chemical composition or tweaking our glue, but we currently can't glue FRT.
Yeah, I think there are issues with some of the adhesive chemistry, so I think there's probably going to be hopefully some more materials becoming available to folks in the future. But yeah, unfortunately, supply is a challenge currently. We had another question come in on designing for curves. Let me pull up my screen here. I've got the NDS available. So when you're designing for curved members, you will have to apply the curvature factor for curved portions of bending members. There we go. So I had briefly alluded to the curvature factor when we talked about table 5.3.1, but it starts here at 5.38, the curvature factor, and it just shows you this adjustment that you will apply, and it does depend on if it's a hardwood or southern pine, or if it's another softwood. That will impact this T over R value. Another thing to note on the curvature factor is that it does not need to apply to straight members of the portion, straight portions of the member. So if you have a member that is partially straight, partially curved, you would only need to apply that curvature factor on the portion that's curved. So that's an important adjustment that you would make when you're designing with curved members. All right. Question on tapering of beams. We do also, I believe that's in, yeah, here we go. There is some language in the NDS here in 5.4 that deals with double tapered curve bending members. So there is a language that deals with if the analysis of that, and if you're dealing with something like a Tudor arch like that, lateral stability, as well as tapered straight bending members. So there is some information in the NDS for the analysis of that. For the actual dimensions of the taper, that's something that you would want to talk to your producer about, your supplier. I'm sure Liz would be willing to have us taper at any angle that we would want, but that you might want to see what's common, what they do more of, because that probably will be easier if they're familiar with it.
My engineer would not want me to say, yeah, we can do anything, but
Right.
I'm going to say, yeah, we can do anything. So
Right. Right. Another question: can glulam be treated for ground contact? That ties in with the CCA question. So I don't know, Liz. Do you happen to know the retention levels when you guys do treated?
Yeah. So we have two retention levels. There's CCA 0.4, which is for above ground, and then there's CCA 0.6, which is for ground contact. We do a lot of picnic pavilions where it's a cantilevered column system. So the columns are buried about 4 feet in the footings of the slab. So we have that higher retention rate for direct ground contact.
Yeah, that's not unusual. That I think you can get glulams treated even with non-CCA products, for ground contact. It's many manufacturers will develop and treat product, for that type of use.
Mm-hmm.
All right, great. Here's a question. I think this one probably will be better directed towards Liz. What's the best way to specify exterior exposed glulams, and who should specify the treatment? Is that something that the architect would be in charge of, or is that something you would typically get from the structural engineer? Or are you guys making the suggestion?
So typically in specs, they'll actually list a few different treatment types just to cover it, because each manufacturer has their own, well, not really their own, but manufacturers use different things. So they'll have a list of treatment options, the CCA, pentachlorophenol, ACQ, etc., to just cover that. That's typically done by the architect. But if you need help with that, we do help people, write edit specs so they are much more tailored to the project at hand. So
this is a question on the adhesive. Is the adhesive as fire resistant as the glue, or would you have to be worried about the adhesive possibly delaminating due to fire? In the requirements for the Glulam adhesive specification, that the number of that specification is currently escaping me. Bob, I'm not sure if you know that one off the top of your head, but
No, I don't.
yeah, but there are requirements that essentially are geared towards the fire resistance of the adhesive, so the member is not going to delaminate when exposed to a fire. The char front would propagate through that adhesive line the same as it would if it were solid wood. So the presence of that adhesive does not have any impact on the char rate of the member.
A note on that, phenol resorcinol, once it cures, it is fully inert, so it doesn't off-gas. It doesn't, it's waterproof, and it doesn't re-liquefy in fire. So that's just specific to phenol resorcinol.
Is that, now here's a question from me to Liz. Is that what you are all typically using, or do you have other adhesives that you use on site as well, or are you typically just phenol resorcinol?
We just use phenol resorcinol for the glue lines, and we use a melamine resin for the finger joints, because I don't know why. I think it has to do with curing them quickly in the radio frequency tunnel, so we can use the material faster than having it sit around all day. But those are the two glues that we use.
Excellent.
There are other glues that are clear or white, but we just don't mess around. We've been using phenol resorcinol forever, so we found that it's really consistent. It works with the treatment types we have available. So that's what we stick with.
Yeah, and I think that, a lot of manufacturers kind of will give a similar answer. We've been using this product. It has worked for us. Might be something different or a different manufacturer than your organization uses, but there's a lot of adhesives out there that comply with the relevant standards.
Yeah, generally, I think in all the engineered wood products, lumber products, you're going to find the adhesives that are resistant to fire. I know many years ago there were some issues with adhesives and finger jointed studs, but those adhesives aren't being used with engineered lumber products. The structural products. I don't think that's a concern.
All right. Some folks asking about connections and shrinkage. So that is something that you do want to be aware of, and I had touched on that briefly in NDS chapter 12 on one of my slides, where we say where we talk about there being a limit on the outer, or the dimension between the outermost rows of fasteners in a single connection. And we have that limit in place because when you start having members in a connection, especially if you have something like a steel side plate and they're very far apart, they can restrain the shrinkage as the member acclimates to the moisture content in situ in its service life. So as the member shrinks and swells, if you have a steel side plate that's not going to shrink and swell with wood, this can lead to splitting around the fasteners and obviously failure associated with the capacity of the fastener. So because of that, you will want to ensure that you are detailing your connections such that you're not restraining movement with the anticipated moisture content. And one thing we know about wood members is that they aren't going to shrink and swell in the long direction. They will shrink and swell in the cross-sectional direction. So when we accommodate, or when we design for that shrinking and swelling, we need to accommodate it in the cross-sectional direction, not necessarily in the longitudinal directions. So that is something to be aware of.
Yeah, Laura, just to add, one of our publications, our Glulam Connection Detail Guide, does provide general guidance on that. So if we go to our website and pull down our Glulam Connection Details, it does have some information, as well as actually, I think last year I did a webinar on just general beam, all structural composite lumber and Glulam beams that discuss some of that. And that webinar is available on our webpage to give it a little plug.
That's apawood.org.
Yep.
Let's see. All right. I think one of you mentioned proof loading of a Glulam member. Is that right? No. Okay.
I did not.
I mentioned that that it will be noted in the trademark if it's the proof loading of the laminations, if that's done during the manufacturing process.
So we did have somebody just question, when you say proof loading, can you elaborate what that actually means?
I don't know if Liz has a better understanding of what proof loading, Glulam, I don't. I can't. I can follow up with that if you get me an email address. So.
Yeah, the only proof loading that I know of and can speak to is the proof loading we do on the finger joints that are a part of tension plies.
Mm-hmm.
So what happens, they get joined together, they go through the microwave, and then they basically get this huge amount of pressure put on them to make sure that there's not going to be any, cracks or issues, and that the joint's nice and strong. It has to be the strongest part of the beam because it's potentially the weakest. So we only do that on the tension ply, so compression or tension, but that's all I can speak to on proof loading.
Yeah, and my understanding is that that's typically where we see it most of the time. And when we say proof loading, it is kind of a load that proves that it can sustain the stress. So from a wood science standpoint, like Liz said, the finger joints are typically the critical location. So that's typically where we see the proof load required the most. All right, Bob, this one you and I probably both can discuss a little bit. It's just specifying simple spans and cantilevers. How do we, and actually all of us probably can speak to this, but when we're specifying something that is going to be like a cantilever, where we would have tension on the top and bottom face depending on the location, how would we go about specifying that versus specifying something for a simple span? Is there a different grade we need to be aware of, or something that folks need to know when specifying a symmetric layup beam, for example?
Well, that's one reason for the balance beam, because that'll, have the tension and compression plies will be the same. So if you're using a balance beam, that'll be accommodated there. One option is the software that I mentioned. That will check your positive and negative bending, in your beam, installed with the top up. So the software would do that check for you if you're specifying multi-span or cantilevered application. So that's another approach. Otherwise, if you're doing hands or you got a spreadsheet or something like that, you're going to have to make sure you check the negative bending, for that application.
Right. So just that balanced versus unbalanced layup. So typically when we're specifying an unbalanced layup, that's something we would see in most commonly in a simple support. application.
Right, and if it's a stocked unbalanced beam, if you're looking at the tables, you look at the multi-span tables. That's what you start looking at. So you got to read the footnotes and what the tables are for when you get into using tables.
Great. All right. Well, we are getting close to the half hour, so what I'm going to do is give it back to Marcy and let her close things out for us. Thank you again to Bob and Liz. This was a really fun session, I know, for me, and I hope that everybody enjoyed it and learned something.